Hello class, my name is E.C. Walker and this is House 2's Chapter 12 semester project. Our team members are myself, Scarlett DeJesus, and Kyle O'Donnell. The learning topics that we have for you today are to discuss system development, specifically the definition, the guidelines, and the phases of system development. We're also going to discuss the importance of project management, feasibility assessment, and information gathering techniques. We'll discuss low-level, procedural, and programming languages, as well as application development tools. And then finally, we'll talk about web page development. So the definition of system development is defined as a set of activities used to build an information system. There are typically three different guidelines to system development. The first one being to group the activities into phases. So this is just making sure that all of your like activities, all of your similar tasks and activities are all grouped together, and you don't have them spread out throughout the life of the project. The second one would be to involve the users. This is making sure that everybody involved with actually using the system has a voice from the beginning on how it's set up. They'll have good ideas. It's very important. And then the third one is just to define the standards. And this is just making sure that you're setting rules in place to make sure that at the end of the project that everything is successful and that you've got positive results. So you just want to define those standards. So there are typically 5 phases to system development. The first one being planning, then analysis, then design, implementation, and finally support and security. Now in addition to these, there's also several other ongoing activities such as project management, feasibility assessment, documentation, and data and information gathering. And we'll actually go further into detail on these items later on in the presentation. So the first stage, or the first phase, the planning phase, this is where you would review and prioritize your project requests, just making sure that the higher priority items have adequate time to be able to do those items. This is where you would allocate your resources, so this is make sure that you have enough people to be able to take care of that as well. This is where you would form your project development team. Typically these are people that are the users, the analysts, and the IT professionals. The next phase is the analysis phase. This is where you would conduct a preliminary investigation. This is typically the system analyst, otherwise known as the system developer, that will do this. Again, we'll talk about this in more depth later on in this presentation. This is where you would perform the detailed analysis activities, such as study the current system, determine the user requirements, and then you would finally recommend a solution. The design phase is the third phase. This is where you would acquire any of the hardware and software if necessary. It may not be necessary because you may actually already have the hardware and or the software that's needed. But if you don't, this is where you would go and purchase those. Some of the leading brands, the top 10, are ones that you're familiar with. It's both Dell and HP, on the hardware side. On the software side, you've got Adobe and Microsoft that are, again, among the top 10 leading manufacturers. Microsoft is also a hardware manufacturer, but they do software as well. The next phase is the implementation phase. This is where you would develop the programs and apps if necessary. Again, you may just be using a system that's cookie cutter. You bring it in, you start using it, tweak it a little bit if you need to. But otherwise, this is where you would actually, if you're not doing that, you would develop the programs and apps if they are necessary. This is where you would install and test the new system. It's where you would train the users, whoever it is that's going to be using it in the future. And this is where you would convert over to the new system. So this is also known as go live, the moment that you flip the switch and that everybody is okay with moving forward, even though they know that there may be a few bugs in the system that they'll have to work out later. And then finally, the support and security phase is the final phase. So this is where you would perform any maintenance activities. Again, this is what I was just discussing, what I just mentioned about any of the few bugs that are still left in the system. This is where you would take care of that. This is where you would monitor the system performance and assess the system security. So these are essentially just making sure that the system is performing as fast as you want. Assessing the system security would be making sure that all of your users have the right administrative privileges to do their job, see if you need to tweak any of those settings, as well as looking at all of your security settings and the likelihood that there will be any kind of a breach or anything like that. So that's it for this section.
Hello class, my name is Scarlett DeJesus, and as EC discussed, there are phases that occur sequentially in order to make sure that a program or app works effectively in the new system. While this is occurring though, we have other things that are going on which I'll now discuss. The system analyst is going to keep things on track, working with a plethora of people to ensure every part is working as it should. To do so, the system analyst will present a feasibility assessment, and a feasibility assessment is just measuring how suitable development of a system will be to the organization. There are 4 different tests, and the first being operational feasibility is an evaluation that looks at how well the system works, if it meets the requirements, and if it's secure. Next, we have our schedule feasibility, and the analyst just looks more towards if there are established deadlines and if they are reasonable. Next is our technical feasibility, and that looks at if it has or can contain the necessary hardware or software for the system to properly and effectively work. And then lastly is our economic feasibility, which evaluates the cost-benefit factor. Now, if any of these 4 evaluations seem to have any discrepancy of any type, the analyst will just need to go back and fix these problems one-on-one so that they are feasible to the system altogether. It is the duty of the system analyst as well as those working within to work together to help build the system. And in doing so, we have techniques to get the utmost gratification for the system. Review documentation pertains to those users who work within the organization to be able to clearly summarize data and information so that it's consistently found to provide information about the organization. When it comes to observing, the system analyst is just going to be taking a look at how the task is performed. And then to get a better in-depth quality information, the analyst would provide surveys throughout the organization to just get more feedback and see how the system works. The most important process the system analyst will do is during the interview process, and this is because there's face-to-face feedback where the analyst can immediately identify problems in the system and can be more timely about about to fix it. Now, the final process the system analyst can do to firsthand hear and observe problems going on in the system is going to be through the JAD session, or Joint Application Design. This approach allows IT professionals and users to come together in lengthy meetings to discuss potential problems and find solutions on the spot. With all those components together, the system analysts will do their own research to see what hardware or softwares have been used on other such websites and kind of looking for more of the success stories in the software and hardware through the media on websites and kind of surfing the web. And this is going to hopefully be able to incorporate into their own system so that it works even better. Breaking down the process of an application development, there are tools that help create the program language and help the computer process these tools into commands. Specifically, there are two types of language. We have a low-level and a high-level language. In the low-level language, we have two separate languages that are machine-dependent. By this, it simply means that it can only be used by a specific computer or device. This slide tells a little bit about each. Machine language uses a series of binary digits, which is an off and on switch pretty much, and the assembly language writes instructions using symbolic code. And in the high-level language, there are four languages that are all machine independent. And because they are machine independent, they're more acceptable to being used on different computer devices as well as operating systems. For the procedural language, it helps further simplify program development, but since it's an assembly language, it must be converted into machine language before the computer can execute the program. By using a compiler or interpreter, it makes it possible to convert into machine language. Therefore, a compiler is a separate program that converts the entire source program into machine language, and an interpreter translates and executes one statement at a time. And that's it for my part.
Hello class, my name is Kyle O'Donnell. In a moment I'm going to go over the benefits of object-oriented programming as well as application development tools, but before I get into that, I wanted to give you guys a brief definition of what both those terms mean. OOP language, also known as object-oriented programming language, is a program language used to implement objects in a program. An application development tool is software that provides a user-friendly environment for building programs and apps. So with application development tools, that's going to make the developer have an easier time building their program. Alright, now we're going to get to some of the benefits of OOP language and application development tools. Both offer the ability to reuse and modify existing objects in different programs. They become more stable over time. So the more you use it, the better and more stable it's going to be. Developers can create applications faster because they don't have to keep rebuilding the same objects. They can just use them over and over again. Some examples of object-oriented programming and application development tools. Java is a big one that's going on right now. C++ or anything in the C programming language realm, and also Microsoft's Visual Studio, which is actually a suite. Some other programming languages and app development tools. 4GL, also known as fourth generation language, it's a non-procedural language with which programmers write English-like instructions to communicate with the database. SQL is a common example that you saw in Microsoft Access. An application generator is a program that creates source code from a specification of a required functionality, and it typically consists of a report writer, forms, and a menu generator. Macro is a series of statements that instructs programs or app of how to complete a task. It enables users to automate difficult, routine, or repetitive tasks in application software or database programs. It's commonly found in Microsoft Excel. Alright, how to create a macro. There's two different ways of going about that. You could either record a macro or you could write a macro. When recording, you're going to need to use a macro recorder and press record. Perform the steps you want the macro to run, and then you press done, and it will work that way. Also, you could just write the macro into a programming language. Alright, now we're going to talk about developing web pages, and I'm going to go over the four main ones, starting off with HTML, also known as Hypertext Markup Language. It's a language used to format documents to display on the web. It's commonly used in a text editor known as Notepad, and the users view the web page in various different web browsers. The next one's going to be XML, also known as Extensible Markup Language. In XML, the web developers create tags that describe how information is displayed, and it separates content to format to allow browser to display content in an appropriate manner. So this is commonly found in mobile browsing, stuff like that, and it's shown differently than you'd see on a desktop computer. Wireless Markup Language, it's a subset of XML, is used by developers to design web pages solely for microbrowsing and different mobile-friendly browsers. We're going to talk about scripts and ActiveX controls. These are short programs run by browsers to add interactivity to the web page. These small programs run inside of other existing programs. Features include animated graphics, scrolling messages, calendars, and the like. Alright, we're going to talk briefly about script languages. Quick definition is that a script language is an interpretive language that is typically easy to use. One certain script language, JavaScript, allows the programmer to add dynamic context and interactive elements to the web page. Perl functions as an interpretive script language hosting text processing capabilities. Perl is commonly found as a report processor. Alright, and last, we're going to talk about Ruby on Rails. Ruby on Rails is an open source framework for developing object-oriented database-driven websites. Ruby on Rails makes developers more productive, providing them with an easy-to-use environment and cutting down on time spent in development.